Hey everyone, I'm here in Ardublock for our level 2 racer class, and today I'm going to try to get our racer to turn at 90 degrees or as close to 90 degrees as I possibly can. So just a complete right hand turn or left hand turn. I haven't quite decided which yet. So first thing we need to do obviously is get our servo blocks, and I'm gonna go ahead and just clone this because I need two of them. I need one for each motor. 10, 11, and I think I'm just gonna go with 0 and 0, which give me a left-hand turn. So here is the issue that we have, though, is that just putting this into the racer is going to just cause it to turn repeatedly. It's just gonna spin around in a circle. That's all it's going to do, because all I've asked it to do is turn left. Furthermore, adding this delay doesn't really help. It doesn't do anything. So what I need to do instead is I need to somehow stack different motion together in order to see exactly what this delay needs to be in order to get a 90-degree turn. So I think what I'm going to try to do is I'm going to get it to move forward, and then I'll get it to turn. So I'm going to go ahead and clone this. I'm going to put it above, and I believe that forward is 10 being 180 and 11 being 0. So what I'm going to do, I'm going to start by having it move forward for a second and then having it turn left for a second and see where that gets me, see what kind of behavior that gives me. And I'll be able to experiment and kind of refine my code from there based on what behavior I see. Alright, so now that I have that code uploaded to my robot, I'm just going to go ahead and drop it down here and see how it behaves. Alright, so we clearly have some problems we need to take care of. Let's jump back into Ardublock and see if we can figure them out. Alright, so a couple things. One, our turn was clearly not 90 degrees. It looks like it was closer to 180 degrees, turning completely around. That's not a huge surprise to me. I kind of mentioned earlier that we're probably going to have to refine our code a little bit. In particular, it's just the delay that I probably need to change, and I have to find the appropriate number. It needs to be turning for a certain amount of time, and that will give me my 90-degree turn. It's clearly not 1 full second. Our other issue was the robot was kind of hard to handle because I didn't implement the button at all. So we're going to fix those two things. The button we can for sure fix pretty easily. We can implement our little code that we've learned before on how to get the robot to stop and not start until the button's been pressed. The proper delay might take us a couple of tries, though. Alright, so remember I need to get my program block instead of the loop do. Get this while loop. Get a test and get this the double equal block. And then I need to find the digital pin. Pin 2, so it represents our button. So we're just going to ask it, is our button still high? In other words, it has not been pressed. Alright. We'll clone this. And let's try to remember what angles give us stopped robots. And that should be 90 and 90. So both of those at 90 degrees. And I'm going to also add like a small, maybe like half-second delay after this while loop. That way, after I press the button, I have half a second to let go of the robot before it starts moving. And then second is this delay. So I said it moved at about 180 degrees, so it like turned completely around rather than turning at a right angle. So I probably, you know, a good guess would be to say, well, let's go from 1000 to 500. All right, let's go ahead and see how our new code behaves. Okay, so we just did 3 trials. They all gave us fairly similar movement. We're definitely closer than we were, but I feel like we still need to go back to the drawing board. All right, so let's recap. First try, millisecond delay of 1,000. Way too far. Turned for far too long. We had it basically turning completely around on the spot. Our second trial, 500. Too short, but definitely closer to what we want. So our second trial, the one we just did, I would say that turn looked like it was about 70 degrees. So it's probably closer than, well, it's definitely closer to 90 degrees than our first try. So I definitely want something that's bigger than 500, but probably not too much bigger. It's probably closer to 500 than it is 1,000. It's just my guess. So I'm going to kind of just like inch it up from 500 milliseconds to 600 milliseconds and see what that gives us. All right, so let's go ahead and see how our recent adjustment changes the movement of the robot. All right, so I think we're gonna go ahead and stop there. Despite the fact that it's still not perfect, we have gotten pretty close to what we were looking for, turning at 90 degrees. Through additional refinement of your code, you can get closer to true 90-degree turns. That can ultimately be very time consuming. Perfection is not really doable, and that's something you may want to consider as you're going through this. A couple other things to keep in mind is that the delays on your code may not be the only thing affecting how far the robot's moving or how quickly it's turning. Things such as the battery life can slow down the robot, and so the turns take longer to accomplish. Similarly, just being on different surfaces, I'm using poster board to do these videos, and the delays that I need to use with this poster board are different from the ones that I would have to use if I was just using the carpet underneath, or if I was using the tiling underneath that. So depending on your surface, you may find that transitioning from one surface to another makes your robot behave differently. So that's something to consider as well. All right, I'll see you guys next time.